Hello friends, in this video we are going to see the part modeling of a flanged coupling using Creo 7.0 software. First, let's see the different functions of a coupling. Coupling is used to connect or couple two shafts for power transmission. Normally, a coupling is used to transmit power from a prime mover to other machines. Couplings also facilitate to disengage two machines for repair work whenever necessary. Now let's see the construction of a flanged coupling. Power from the driving shaft will be transmitted to the flange through the key and keyway arrangement. Then the power from the first flange will be transmitted into the second flange through the four bolts and nut arrangement. Then the power from the second flange will be transmitted into the driven shaft through the key and keyway arrangement, which is shown here. While assembling the two flanges, generally a shift of 90 degree is provided between the positions of the first key and the second key. Now let's move on to the modeling of individual parts. There are 5 parts in this particular assembly: flange, shaft, taper key, hexagonal bolt and hexagonal nut. Let's start with the modeling of the flange. Open a new file, change the file name into flange, remove the tick mark on use default template, click OK. Select millimeter Newton second part solid absolute. Give OK. We will start from the right plane. Select the right plane as the sketch plane. Select the sketch option. Click on the sketch view. Go to view option. Switch off the axis display and plane display. Go to sketch. Draw the center lines. The inner diameter of the flange is 45 mm and the outer diameter of the flange is 190 mm. Go to circle command, select the center and point option, draw the inner circle, draw the outer circle. The inner circle diameter is 45 and the outer circle diameter is 190. Click on refit, give OK. Go to extrude option, slightly tilt it. The depth of extrusion is 20 mm. Change to 20, give OK. Now we need to draw the hub portion of the flange. Go to sketch, select the sketch plane, click on the sketch, select sketch view, go to references, include references, close it, go to circle command, select center and point, draw the inner circle. The outer diameter of the hub is 90 mm. So go to circle, select the center and point, draw the outer circle, change the diameter to 90 mm. Slightly tilt it, give OK, go to extrude. We need to extrude it 75 minus 20 mm. So change the length of extrusion as 75 minus 20. Enter, give OK. Now we have to create the 4 holes of diameter 12 mm and the pitch circle diameter is 140 mm. So go to sketch option, select the sketch plane, click on the sketch, select the sketch view, select the construction mode, select the circle with center and point, draw the pitch circle. The diameter of the pitch circle is 140, so the radius is 70 mm. Enter. Now we need to create the first hole of diameter 12 mm. Switch off the construction mode. Go to circle, select center and point, Select the intersection point, draw the first hole, change the diameter of the hole into 12 mm, give OK, slightly tilt it, go to extrude command, change the direction of extrusion, extrude throughout, give OK. Now we have created the first hole. Using pattern option we can create the other 3 holes. Select the extruded part, select the pattern, select the geometry pattern, select the axis option, click on the axis. Number of members 4. We need only 4 items. Give OK. Now we have created all the 4 holes of diameter 12 mm. We need to round off the sharp edges at 3 different places. So go to round command, select the edge. Let's change the radius into 2 mm. Enter. Give OK. Once again select the round option. Select the edge. Give OK. Select the round option once again. Select the edge. Give OK. Now we have rounded off all the 3 edges. Now we have to create the keyway. From this diagram we can understand that the depth of the keyway is 45 minus 39.5, which is equal to 5.5. Instead of creating the keyway, let's draw the key and remove the material to get the keyway. So go to sketch option, select the front plane, click on the sketch, select the sketch view, switch on the hidden line option. Go to line option, select line chain. Let's start the key. It is given that the taper value is 1:100. So there will be a reduction of 1 mm over a length of 100 mm. But in this case we have only 80 mm length. So the reduction will be 0.8 mm. And the thickness of the smaller end would be 9 minus 0.8 mm, which is equal to 8.2 mm. We know the total length of the key. So let's dimension the total length. The distance between the center of the shaft to the bottom surface of the keyway is half the diameter minus 5.5 mm. That is 22.5 minus 5.5. This value is 22.5 minus 5.5. And the thickness of the smaller end is 9 minus 0.8, which is equal to 8.2 mm. And the thickness of the larger end is 9 mm. And total length of the key is 80 mm. Give OK. Go to extrude option. The width of the key is 14 mm. So change the depth into 14. Change the option to shading with reflections. Remove material. Select extrude symmetrically on both the sides of the sketch plane. Give OK. Now we have created the keyway. Now let's change the color of the flange. Go to view option. Select appearances. Select the color. Select the part option. Click on the part. Enter. Let's close the model. Now let's model the second part, which is shaft. Open a new file, part, change the file name as shaft, remove the tick mark, give OK. Select millimeter Newton second, part solid absolute, give OK. Select the right plane, select the sketch option, select the sketch view, switch off the plane display and axis display, draw the center lines, Draw the circle of diameter 45 mm. Go to circle command, select center and point, select the origin, change the diameter into 45 mm, refit, give OK, select extrude option, switch on the plane display and axis display. The length of the shaft must be more than 90 mm. Let's assume the length of the shaft is 120. Enter. Q. OK. Go to standard orientation. Now we have to create the keyway. We know the depth of the keyway is 5.5 mm. So go to sketch option. Select the front plane. Click on the sketch. Select the sketch view. Go to line command. Select the line chain. Draw the keyway. We know the depth of the keyway is 5.5 mm. The gap between the center of the shaft to the bottom surface of the keyway is 17 mm. That is 22.5 minus 5.5. So this value will be radius value 22.5 minus depth of keyway, which is 5.5 mm. Length of the keyway is 90 mm. 90 mm. Give OK. Go to extrude option. Select the option extrude symmetrically on both the sides of the sketch plane. The width of the key is 14 mm. Remove material. Give OK. Now we have to create a curved surface on this particular end. So go to round option. Select the edge. Change the radius into 5.5 mm. Give OK. Now we have to create a chamfer of 2 mm on the left edge. So go to chamfer option. Select the edge. Select the option 45 into D. Change the D value as 2 mm. Enter. Q OK. Now let's change the color of the shaft. Go to view. Select appearances. Select the color into yellow. Select the part option. Click on the part. Now we have changed the color of the part. Go to standard orientation. Now close this part. Now we have to model the taper key. Open a new file. Change the file name. Remove the tick mark. Give OK. Select millimeter Newton second part solid absolute. Give OK. Select the front plane. Click on the sketch. Select the sketch view. Go to view. Switch up the reference planes and reference axis. Go to sketch option. Go to line option. Select line chain. Draw the taper key. We know the length of the taper key. We know the thickness of the larger end. We know the thickness of the shorter end. Now let's change the dimensions. Select all the dimensions. Go to modify dimension. Remove the tick mark on regenerate. Thickness of the smaller end is 8.2. Thickness of the larger end is 9 mm. Total length of the key is 80 mm. Give OK. From this diagram we can understand the maximum thickness of the key is 9 mm and the minimum thickness of the key is 8.2 mm and the total length of the key is 80 mm. Give OK. Select extrude option. Select extrude symmetrically on both sides of the sketch plane. Width of the taper key is 14 mm. Give OK. Now let's change the color of the key. Go to view option. Select appearances. Select the green color. Select the part option. Click on the part. To differentiate the end of thickness 9 mm, let's change its color to red. Select the red color. Select the surface. Click on the surface. Now we have changed the color of the thicker end into red. Now let's close the model. Now we have to model the fourth item, which is hexagonal bolt. Open a new file. Change the file name into bolt. Remove the tick mark on use default template. Give OK. Select millimeter Newton second part solid absolute. Give OK. The size of the bolt is given. We have to create M12 thread on the bolt. Let's start with the head portion of the bolt. Go to sketch option. Select the top plane. Select sketch. Select the sketch view. Go to palette option. Select polygons. Select six-sided polygon. Click and drag it. Move the center of the hexagon into the origin point. Give OK. The size of the bolt is 12 mm. Let's keep the same value as the side length of the hexagon. So change the side length into 12 mm. Enter. Refit. Give OK. Go to extrude option. Switch on the reference planes and reference axis. The thickness of the head is 8 mm. Give OK. Now we have to create a taper portion at the top head. Select the sketch option. Select the top surface. Click on the sketch. Click on the sketch view. Include the references. Close it. Go to circle command. Select center and point. Draw a circle which becomes tangent to the reference lines. Give OK. Select extrude. Change the direction of extrusion. Select options. Click on add taper. Change the value into -45. Click on the change material direction to extrude to other side of the sketch. Give OK. Now we have created the head portion of the bolt. We have to create the threaded portion. Go to sketch option. Select the bottom surface. Click on the sketch. Select the sketch view. Go to circle option. Select center and point. Draw a circle. The diameter of the bolt is 12 mm. Change the diameter into 12. Enter. Give OK. Select extrude. The total length of the bolt excluding the head portion is 34 plus 18. 34 plus 18. Give OK. Now we need to include a chamfer at this entry end. Go to chamfer command. Click on the edge and select 45 into D. Change it to 0.8 mm. Give OK. Now let's include a fillet at this particular edge. Go to round option. Select the edge.
Change the fillet radius into 1 mm. Give OK. Now we have to create the thread on the 12 mm diameter portion. Go to sweep command, select helical sweep, select references, click on define, click on the right plane, sketch, sketch view, include references, click on the left boundary and click on the bottom boundary, close it, go to line command, select line chain, draw a vertical line. The length of the threaded portion is 18 mm. 18 mm. Select the center line, draw the center line, give OK. Now we have to draw the sketch of the thread. Select sketch, go to line option, select line chain, start from the lower corner, go to constraint, select equal, click on the first line, click on the second line, click on the third line. Let's make the length of the triangle into 1.2. Let's include a fillet on this particular corner. Go to fillet, select the first line and select the second line. Change the fillet radius into 0.16. Enter. Give OK. Change the pitch value into 1.75. Enter. Remove material. Give OK. Now we have created the thread. Only thing is this portion and the other portion to be opened. So go to sketch option, select the sketch plane, click on sketch. Now let's draw lines on the outer periphery of the profile. Go to line, select line chain. Let's start from here. Go to arc option, select 3-point arc. Select the first point, select the last point, select the intermediate point. Give OK. Go to extrude option, change the direction of extrusion. Select extrude to intersect with all surfaces. Remove material and give OK. Now we have to remove the material on this end also. So go to sketch, select the surface, click on sketch, go to line option, select line chain, draw a line. Go to arc, select 3-point arc. Give OK. Select extrude. Change the direction of extrusion. Select extrude to intersect with all surfaces. Remove material. Give OK. Go to standard orientation. Now we have created the bolt. Now let's change the color of the bolt. Go to view option. Go to appearances. Select the brown color. Select the part option. Click on the part. And now we have changed the color of the bolt. Now let's close the part. Now we have to model the last part, which is hexagonal nut. Open a new file, change the part name into nut, remove the tick mark on use default template, give OK, select millimeter Newton second part solid absolute, give OK, select the top plane, click on the sketch, click on the sketch view, switch off the reference planes and reference axis. Let's draw the center lines. We have to draw the hexagonal nut. So go to palette option, select polygons, select 6-sided hexagon, drag it and keep it. Now move the center point to the origin, select OK. Since we are using M12 thread, let's keep the side length as 12 mm. Click on refit, give OK, select extrude. The thickness of the nut is 10 mm. Give OK. Now we have to create the tapered surface at the corners. Go to sketch option, select the top surface as the sketch plane, click on the sketch, click on the sketch view, select the references, click on any two edges of the hexagon, close it, go to circle option, select center and point, draw a circle which is tangent to this references, give OK, slightly tilt it, select extrude option, change the direction of extrusion, go to options, click on add taper, change the value into -45, click on change material direction to extrude other side of sketch, give OK. Now we have to create a hole for making internal threads. Select the sketch option, select the top surface, click on the sketch, select the sketch view, go to circle command, select center and point option, draw a circle. For making the M12 thread, let's consider the diameter of the hole as 10.5 mm. Click OK. Go to extrude option, change direction, give OK. Now we have to create the helical thread. So go to sweep option, select the helical sweep, click on the references, click on define, select the front plane, click on sketch, click on sketch view, select the hidden line option, include the center line, include references, close it. So now we need to draw a vertical line through the reference line. Go to line option, select line chain, start the line below the lower part of the nut and extend the line little beyond the top surface. Select OK. Change the pitch value into 1.75. Click on sketch. Go to line command. Select line chain. Draw the profile of the thread. Go to constraints. Select the equal constraint. Click on the first line. Click on the second line and the third one. Change the side length of the triangle into 1.2 mm. Now let's include a fillet between the two inclined lines. Go to fillet option, click on the first line, click on the second line. Let's change the radius of fillet as 0.16 millimeters. Give OK. Change the view option into shading with reflections. Remove material. Now we have created the thread. Click OK. Now let's change the color of the nut. Go to view option. Select appearances. Select the dark brown color. Select the part. Click on the part. Now we have created the nut as per the dimensions. Select standard orientations. Now we have completed the part modeling of all the 5 components of flanged coupling. Close the model.
Thanks for watching this video. Hope you have enjoyed. Don't forget to like this video, give your comments, share it with your friends, and don't forget to subscribe this channel.